Welcome to The Explainer. Today, we are taking you on a Mad Max-style Fury Road to an A star. We're navigating the absolute wasteland of tricky Cambridge computer science questions to help you claim your grade treasure. Specifically, we're decoding the examiner's rubric to help you master asymmetric encryption for the Information Technology 9626 exam. Now, whether you are taking 0417, 0478, 2210, 9618, or 9626, you know this topic is an absolute heavyweight. But let's be honest, we've all been there, staring at a blank page, panicking. In our scenario today, we have two types of students. There's Alex, who overloads his answers with raw computer science facts, but provides absolutely zero analysis. And then there's Sam, who just rushes through the paper, completely missing the command word requirements, leaving huge marks on the table. Today, we're pulling back the curtain to see exactly what principal examiners are searching for so you don't end up losing marks like Alex and Sam.
Let's kick things off with a high-stakes insight straight from the examiners themselves. When looking at past paper responses, they constantly note that, quote, top-performing students exhibit connected, conceptual understanding transferable to unfamiliar contexts. So, what does this actually mean for your study strategy? Well, it means rote memorization won't save you out here in the exam wasteland. If you're like Alex, just regurgitating textbook definitions, the examiners will see right through it. The exam is absolutely going to throw curveballs at you. You might get a scenario about a hospital, a bank, or a secure corporate network, and you have to apply your knowledge dynamically to those brand new scenarios. That connected understanding is your golden ticket.
Before we dive deep into the exam strategy, let's just ground ourselves in the core mechanics of Section 1.3. Asymmetric encryption utilizes a mathematically linked pair of keys, one private and one public, to secure data. Think of it like a highly specific padlock and a unique key. Data locked or encrypted by one can literally only be unlocked or decrypted by the other. Now, Alex would just write down this exact definition on the exam and expect full marks. But here's the thing. Understanding exactly how these two interact is just the bedrock. It's the starting line, not the finish line. We need to take this basic concept and learn how to analyze it to get those top-tier marks. So here is our roadmap for today's masterclass. First up, cracking the encryption exam. Second, mastering core principles. Third, we'll look at the procedural framework. Fourth, critical analysis and evaluation. And finally, top examiner warnings. Let's get right into it. Section 1, cracking the encryption exam and decoding those tricky syllabus requirements. Okay, academic benchmarks for this topic follow one very simple, unbreakable rule. Analytical depth is strictly greater than superficial breadth. Examiners want to see logical, structured reasoning over a giant, broad list of random facts. Writing down 10 generic facts about how public keys are shared over the internet will actually earn you fewer marks than writing down 3 highly detailed, context-specific points proving exactly how the keys interact in the specific scenario given in a question. This is where command words come in. If the command word is evaluate and you just list facts, you're giving breadth when they desperately want depth. Moving right along to Section 2, mastering core principles, or what we call the theoretical architecture. The theoretical architecture of a winning A-star answer rests on these 3 pillars. First, precise definitions. You cannot be vague. Second, causal relationships. For example, if a message is encrypted with a public key, why is it that only the private key can decrypt it? Explain the why, not just the what. And third, integration. Examiner reports explicitly highlight that referencing cross-topic connections achieves significantly higher marks. So connect your encryption knowledge to networks, data security, and communication protocols. To do this effectively, top students use the PEAL framework. That stands for point, evidence, explanation, and link. You make your point about the encryption key, provide evidence from the exam scenario, explain the causal relationship, and link it back to the question's core demand. Before we continue, subscribe to our YouTube channel Ace the Exams at acexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. All right, we're back, and this brings us to a really crucial question that plagues so many candidates when they face unfamiliar contexts on exam day. Why do students find evaluating evidence and drawing conclusions so incredibly hard? Well, it's usually exam panic. Let's look at Sam. When the clock is ticking, Sam rushes, completely misses the specific command words like analyze or discuss, and defaults to just describing what asymmetric encryption is. Sam leaves all the evaluation marks blank because of the sheer pressure of the ticking clock. To solve that panic problem, we move to Section 3, the procedural framework. This is all about standardized execution.
To beat that exam panic and stop acting like Sam, you need a systematic safety net. We call this the computer science success blueprint. Step 1, deconstruct the question. Literally circle the command words. Step 2, extract relevant data from the scenario. Step 3, select your analytical framework like the Peel method we just talked about. Step 4, execute with clear notation, writing out your logical steps clearly. And Step 5, present with correct professional terminology. Following this exact standardized sequence ensures you never, ever miss those crucial method marks, no matter how weird the question's context is.
Notice the stark contrast here between what average candidates write and the evaluative thinking demonstrated by top-scoring candidates. On the left, we have Alex and Sam's initial attempts: vague definitions, totally lacking specific context, and relying on superficial breadth. But when they apply our framework, their answers transform into the right side. Red pen marks turn into green check marks. They start questioning assumptions, considering different perspectives on network security, and justifying their decisions with hard evidence from the prompt. It's a total transformation. Stop scrolling, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to aceexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's jump straight into Section 4, Critical Analysis and Evaluation. This is where we learn how to hit those higher order objectives, and it's time for our interactive workshop.
This table perfectly breaks down the framework levels. If you are just stating basic facts, you're stuck at the descriptive level. To max out your grade, you must push past this. Imagine a complex computer science data table on the screen right now, showing encryption key sizes and cracking times. If I put 60 seconds on the clock, could you scan that data and extract the core trend? An analytical answer would interpret the relationship between key size and processing time, but an evaluative answer, the A-star answer, would compare different encryption approaches and justify a specific recommendation for the company in the prompt. You have to climb this ladder.
Let's try Challenge 2, Find the Flaw. When the exam asks you to evaluate evidence, this slide right here is the exact checklist you should be running through in your mind. Listen to this flawed sample paragraph from Alex. Asymmetric encryption is the best because it uses 2 keys, making it perfectly secure for the company. Can you spot the flaw? It completely ignores this checklist. Alex didn't identify any limitations, like the slower processing speed of asymmetric encryption. He didn't question the assumptions made about the company's hardware capabilities. To evaluate properly, you must weigh these factors and explicitly state their effect on the final conclusions.
Now for the most critical part of our explainer, Section 5, Top Examiner Warnings. These are the insider pitfalls you absolutely must avoid.
Here is Challenge 3, Speed Writing. If you only had 30 seconds to write one perfect Peel paragraph, what's the most vital thing to include? It's the method mark strategy. Never, ever skip showing your procedural steps. As the principal examiners explicitly warn, students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. When you are mapping out exactly how a private key decrypts a hash to verify a digital signature, write out the logical sequence step by step. You have to let the examiner see your brain working on the page.
Let's look at the top 3 traps students fall into every single examination series. Trap 1, answers are simply too vague. Trap 2, forgetting to check format and presentation. And Trap 3, which is literally the biggest killer, answers are not specific to the given context. This all comes down to the time management matrix. If you spend 20 minutes brain-dumping facts for a 4-mark question, you're going to rush the 10-mark context question at the end of the paper. You'll end up writing a generic answer about data instead of highly confidential patient medical records, and you will lose those contextual marks instantly.
So let's recap our complete computer science answering system. You need to follow 3 rules to guarantee top marks. Rule 1, command word decoding. Rule 2, apply the Peel framework to every long-form answer. Rule 3, use a strict time management matrix. Rote memorization of public and private keys isn't enough. You must apply the concepts professionally to the specific scenario given. Master the context, apply professional terminology. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. I will leave you with this final thought to challenge you as you head right into your past paper practice. Ask yourself after every single paragraph you write, is my answer just descriptive or is it truly evaluative? Push yourself to question the data, justify your conclusions, and show you're working. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Acing the exams, your Cambridge success starts here.